Aloha and welcome. We're going to be talking this chapter about network attacks. Specifically, in this section, we're going to be talking about the denial of service attacks, DNS poisoning, and domain hijacking. So I'm going to start out by opening up our textbook as usual, and we're going to be taking a look here. And you can see that we're in chapter 4. We're looking at section 1 on distributed denial of service attacks, DNS poisoning, and domain hijacking here. So denial of service attack is simply an attack where it's an attack against the network resource. The aim of it is to prevent, disrupt, or delay authorized users from accessing the network resource. So you're trying to bring down that system essentially. So distributed denial of service attack is the same thing, except that it's going to be launched from a number of different systems. Often it's going to be a botnet that attacks. So remember we talked about botnets before. You've got a botnet that has thousands, if not hundreds of thousands of computers in it, all launching the attack that they get the instructions from their command and control server. They send out their attack and they try to flood that target. So we've got several different types of DDoS attacks. We've got the network-based DDoS attack. It's also called a volume-based DDoS attack. The point of that one is to exhaust the target system's network bandwidth. So there's different types out there. You can do UDP or ICMP floods. These are network-based DDoS attacks. A ping attack, basically, where you're just pinging constantly from thousands and thousands of computers. There's protocol-based DDoS attacks. They're known as state exhaustion DDoS attacks. And that's where you're trying to exhaust the target system's network resources or the resources of a network infrastructure equipment, such as a firewall or a load balancer. So protocol-based DDoS attack exploits the weaknesses of the network layer, which is OSI layer 3, and the transport layer, which is OSI layer 4 protocols, to create maliciously configured protocol packets. An example they give is a TCP SYN flood as an example of a DDoS attack. The last one is the application layer DDoS attack, and that's known as an OSI layer 3 or layer 7 DDoS attack. And that's where you're trying to exhaust specific functions or features of a program. So the example they give here is like overloading a web server with HTTP requests. And HTTP is going to be an application layer or layer 7 DDoS attacks. And we're talking about the different layers here. What we're talking about is the 7 layers of the OSI model. And that is going to be the highest level, which is like HTTP, the program level. That's going to be application. Then we've got the presentation layer. You don't need to worry about that. Session layer, that's where we're going to be, don't worry about the session layer either. But transport and network we talk about. Essentially, think of your data. When your data comes in, it comes in at the physical layer, and it goes up to the data link, and then it goes, you've got network, transport, session, presentation, application. So it goes through all these different layers when you're sending and receiving information. It goes through these different layers. Different things are being handled at different points. And we didn't look at the Wireshark, but if you use a tool like Wireshark, you can see, all the different information for these different layers when the information's coming in on the wire. But don't worry about that so much. Just understand that when they're talking about layer 7, they mean the application layer. They're talking about like applications like HTTP. When they're talking about the transport layer, we're talking about layer 4, or the network, it's layer 3. So this is what they're referring here. So when they say it's a layer 7 attack, when they're talking about layer 7, they just mean they're trying to overwhelm the program. Other ones are going to be, trying to, I think, exploit layers 4 and 3 as well. But so when we look over here, they're talking about the network at layer 3 and then transport at layer 4. So those are the two that they're referring to here. And layer 7 is the applications over here. And we've got a nice example of overwhelming a server and how it's used to flood the network from all these different places. Operational technology. So operational technology, most IT that we talk about is dealing with data and data systems. Operational technology actually deals with hardware and the software that interacts with that hardware directly. And that's used often to monitor and control industrial equipment. So this is really scary stuff. So This is the type of stuff that you'll find in industrial control systems, SCADA, things like that, and they are used in a lot of power plants and manufacturing processes. So one of the issues that they have is they're particularly vulnerable to DDoS attacks because the legacy hardware and software are often used in operational technology. So we've got older things here. Maybe they're not being updated as often, or maybe they're beyond their lifespans in terms of updates and whatnot. So yeah, so OT devices, they've got limited resources and capabilities and are less likely to be secured against modern day attacks. So that's something, and some things are a little bit harder to update as well. If you've got something that's embedded into some of these systems, sometimes those aren't updated as often as you would think they should be. So operational technology, that's another prime target for DDoS attacks. We're getting into attack methods here. We're going to talk about amplified DDoS attacks and reflected DDoS attacks. So amplified DDoS attacks are actually a type of reflected DDoS attack. The difference really is that amplified is for a smaller input, you're putting out a larger output. So it's the way these attacks are pulled off. So when you've got an amplified DDoS attack, that's going to be exploiting the response mechanism of certain protocols to amplify the traffic volume towards a target. And the example they give here is a DNS amplification attack requests all records associated with a domain from multiple DNS servers using the target's IP as the source. And then, because what they're doing is they're spoofing somebody else's IP address, when that response comes, it's all going to go to that target. So if you get a bunch of people putting out there, hey, I want this, full DNS record, and it's dumping all these DNS records at that target. If everybody, faked that they were coming from, let's say this system, that they're targeting, then all of a sudden they're going to get, bombarded with all of these different things. And this is called an amplified one because a small request can result in a large response. So that's why we call it amplified. Then reflected, again, here they say that a DDoS attack method exploiting the response mechanism of certain protocols to redirect traffic from third-party services towards a target. And this also it relies on the fact that they're spoofing somebody else's IP address. So a reflected UDP flood attack, it's going to send spoofed UDP requests to multiple public UDP services using the target's IP as the source, thereby flooding the target with overwhelming UDP responses. So there's a chart down here where they break up the differences between them, but just remember that an amplified attack is a type of reflected attack. It's just that the input to, the inputs that you have are going to be, dwarfed by the response that it gets. It's not even. So you send a small request and you get a big output from it. And because you're spoofing their IP address in both cases, so the responses are going to go to that target system in order to overwhelm them. We talked about DNS earlier. I was explaining to you a little bit about DNS system. So DNS is the domain name system. So when you type in an address up here, like here in the address bar, we have zybooks.com. If I've never been there before, what's going to happen is your system is going to go out. It's going to look up the IP address. So computers out on the internet, they're using this thing called an IP address and internet protocol address, basically. So you've got these IP addresses. So we know the common names like CNN.com or something like that. So when we type in CNN.com, it needs to translate that into an IP address for us. So it needs to look it up at this DNS server. So the DNS server, it's hierarchical. So in nature, so you've got the top level domain, then you've got other ones. But this whole process of looking it up, it's called DNS resolution. It's also called DNS lookup or DNS query. So this is how we get those IP addresses from the domain name that we're used to using. So DNS is broken up into different zones. We got the DNS zone. It's a portion of the DNS namespace that is managed by an administrator or specific organization. Then we have the authoritative name server, and that's the DNS server that manages a domain's configuration, also known as the domain's DNS record. So an example they give is an authoritative name server for google.com is going to be ns1.google.com, and that NS stands for name server. We also have domain reputations, domain reputations are a measure of domain's trustworthiness based on historical data. This is often used by spam blockers. So if you have a bad domain reputation, you may find that your emails don't get delivered. So if you have, let's say you signed up for a web hosting at a certain place, and you find that all of a sudden your emails to your customers aren't going through, and then you find out later that, oh yeah, so you look up the domain trustworthiness, the domain reputation, and you find out that the server or the network segment that your server is on is considered to have a low reputation because somebody else on there has a server that's sending out spam. So you'll find that at some of the cheaper hosting services that are out there. So DNS attacks, we've got domain hijacking. That's the act of changing the registration information of a domain without the knowledge or consent of the domain owner. You can do that through technical ways, or you can do that through social engineering. We showed an example of social engineering early on in the course where we had a woman that called up a phone company and got a person's record changed. You can do the same thing with DNS if you were to work on that. You can do it through social engineering, or you can go the technical route. Technical route is going to be a lot harder. There's also URL redirection that's going to divert a user to a malicious website. So you can do that as part of a phishing email where you have text and then it actually sends them to a different place. Or you can use the system's host file. So if you're in a Windows system, you have a host file in your computer that you can modify, and it has names to addresses. So you can look it up. Look up, it may be in, I forget where exactly it is, like Windows, I think it's something like Windows System 32, etc., somewhere like that. And there's a host file in there. And if you go in there and modify, put in like cnn.com and then put in an address for whatever you want, when you do type in that name, you'll see that it goes to that site. So this is a type of poisoning as well. So if somebody installs some malware on your system that goes and modifies that file, or I know some, I think they're called, they're pups, they're different pup, software that you can install that'll do things like that. They'll change it so that you're looking at their DNS server so they can serve you whatever you want and whatever they want. So that's not a really nice thing. So that's DNS poisoning. So or DNS DNS cache poisoning or DNS spoofing. The idea is essentially that you're going to be changing the, or wait, hold on. No, I skipped a beat here. So that was the URL redirection that we're talking about. Then we've got DNS poisoning or DNS cache poisoning or DNS spoofing. That's when we're going to be redirecting a user to a malicious website by modifying the user's DNS query. So that can be several different ways here. So you can do that by replacing an IP address in a DNS record. So where's that DNS record held? Is it one of the intermediary ones in that hierarchical structure? It could be that, or it could be at the root. It just depends on how they've done it. So also mentioned here that a DNS poisoning attack can be performed by various methods, such as installing malware on a user's computer. Like I was mentioning a second ago, you can do that and have it modify your DNS accordingly. You can also modify a DNS message in transit. That's a lot more technically challenging. Or you can modify the DNS server settings on a router because routers hold DNS information as well. Or you can modify the DNS records on a DNS server, and that's even harder to do. So all these are different examples of DNS poisoning. And they have examples of it here for you to watch. The last thing we're going to talk about is DNS security. So DNSSEC, or domain name system security extensions. So these DNSSEC, that's a set of extensions. They're going to allow you to use cryptographic authentication of DNS. So the nice thing about this is it uses digital signatures, and through using digital signatures, you can guarantee that the information that you got was from the proper origin. You know it's coming from the right place. You also know that it hasn't been modified in transit. So it gives you both that data origin authentication and the data integrity, and it's doing that through digital signatures, which we talked about previously. So if you have any questions about this, feel free to look back at what we were talking about with digital signatures just in the last chapter to understand that you get these two properties out of it. And by doing that, we avoid the domain name poisoning from several of the methods that we mentioned here. So anyway, if you have any questions about any of this material, I know that there's a lot of networking stuff in here that may be a little bit foreign to you, talking about the OSI layers and things like that. If you have any questions, feel free to ask me. That's what I'm here for. Reach out. We'll set up a Zoom meeting, or I can send you more resources to work with. But yeah, just let me know when you need help. Other than that, I'll see you in the next video. Aloha.